Introduction. Background of study. Industrialized building system or IBS is defined as a construction system which components are manufactured in a factory on or off-site, positioned and assembled into a structure with minimum additional site work. The IBS construction method can reduce wastage of resources besides providing good quality results for consumers. IBS was initiated in Malaysia since the 1960s, right after the Ministry of Housing and Local Government visited to several European municipalities with the objective of assessing their housing development plans. Objective. The purpose of the study is to identify the related evaluation of the IBS activity at higher education hub buildings in Pagoh, Johor. There are several objectives that would be priority in order to achieve the aim of this study. The objectives are: the first one is to investigate and review the connection system used in the building from IBS perspective. Second one is to identify on the IBS score of the investigated building. And the last one is to generate the suitable method of work to install and transport the IBS component. Location of the project. This study is actually run at the Concrete Laboratory at Block F, which is located on UTHM Pagoh, Johor, as you can see in the map below. Standard and software implementation. This project was carried out by Follow and Refer the Modular Coordination in Building MS1064 and CIS 18 2018 Manual for IBS Content Scoring System IBS score. This project also implements AutoCAD software as tool for 2D of the technical drawing.
For the task 1, break down the structure and review the connection system used in the building for IBS perspective. So the selected building is located in UTHM Pagoh campus. The building is a concrete laboratory which conduct basis properties tests on concrete ingredient as well as quality control tests on cement, aggregate and concrete. As shown in the first figure is a plan view. We use the AutoCAD software to apply the IBS to the building. So the figure next right is the structure design of the concrete laboratory. So for the review of connection system used in the building for IBS perspective, first is the component of connection is precast hollow core slab. The slab design, which is made of precast hollow core slab, it was created by embedding height, tensile strength, pre-stressed stand or single wire within the element. These elements are cast in one step along a manufacturing bed without the use of any formwork. Second is a precast panel. The precast panels used is the type of wall. It's connected to adjacent wall panel through a crude tube. Wall are cast in a flat position at the building site, but they are still classified as precast, not a site case. So for the third component of connection is the column and beam connection. The precast concrete column is a load bearing to support beam and slab as the structural system. These precast concrete columns are reinforced with 4 steel rebar for additional tensile and compressive strength to resist bending force. So it also displays how the connection beam connect to the wall via the connection plate type. The beam are extend beyond the column support and provide bearing for smaller drop in beams between them. So the fourth one is the fin plate connection. The fin plate connection are easy to fabricate and erect. It consists of the length of the plate welded to the supporting beam or column in offside and then bolted to the supported beam web on-site. And the last one, slab to beam connection. So the hollow core slab are set on bearing pad on precast beam. Steel reinforcing bar are inserted into the slab keyway to span the joint. The joint is grouted solid. The slab may remain unstopped as shown or topped with several inches of cast in place concrete.
Bismillahirrahmanirrahim. Okay, so the next topic is 3.0 Industrialized Building System IBS score. Okay, IBS score is a systematic and organized evaluation system that may be used to measure the utilization of IBS in a consistent manner. Okay, next is the IBS scoring system prioritize the following character. First, the use of prefabricated and precast component. Second, component manufacture off-site. Third, the employment of standardized component. Next is repeatability. Lastly, use the modular coordination principle in your design. Okay, next, there are three part of component for IBS score, which is part one, structural system. This part focus on upper structure only, like slab, beam, column, and roof. Next is part two, wall system. This part is focused for various type of wall system use. And lastly, part three, others simplify construction solution. They are focused on upper part, which standardized component based on Malaysian standard, layout repetition, the use of modular unit, and modular grid line in drawing, and lastly, a building information modeling (BIM). Okay, next is the calculation for IBS. This calculation is based on concrete lab. Part one, part one structural system. The total of part one include ground floor and roof. Total area is 600 meter square. The coverage total is 1 and IBS score is 25. Okay, next is part number 2. For part 2 wall system, IBS factor is 0 because it use brick, brick wall, and the IBS score is 0. Next is other simplified construction solution. Okay, for this part is total is 14, and for total IBS score include part 1, part 2 and part 3 is 39 point.
Precast installation method. The first one is setting out. Setting out is to identify the correct position of the precast element to be placed. The reference line and offset line should be specified. The second one is lifting and installation. Lift and reach the panel to its designated location using wire rope while carefully inspecting the precast element hoisting condition. The panel must be adjusted to the correct position and secure with diagonal support. The third one is grouting work. After inspecting the joint, use the non-shrink mortar to cover the gaps along the bottom edge and the inner side of the panel to reduce the risk of cracking. Leave the installed panel alone for at least 24 hours. The lastly is joint casting and sealing. For the panel with cast in situ joint, should be correctly installed the joint rebar as required. Horizontal component installation. The first one is setting out. During installation, the reference line and offset line were set to calculate the required side alignment and level of the precast slab or beam components. The second one is lifting and installation. Install temporary support to support the precast slab or beam part. Lift and reach the panel to its designated location using wire rope while carefully inspecting the precast alignment hoisting condition. The third one is joint casting and sealing. Place and lap the rebar as needed for the component with cast in situ joint. Set up the formwork for the casting joint and pour the concrete. The form is removed after the strength as required. SCJ Concrete Bukit Gambir plant, which is quite close to the building site, has been chosen as the concrete batching plant. Precast transportation. For planning work, precast concrete installation require carefully planning. The following element must be clearly planned. The first one is method and sequence of assembly and erection. The method of providing temporary support, provision for final structure connection and the joint details, erection tolerance, handling and rigging requirements. Preparatory work item and checklist. The first step should be to ensure that the site is accessible for the delivery of precast element. Checking the delivery checklist to ensure that the right kind, quality and panel identification are used. Checking the crane capacity and operating for the proper hoisting of precast concrete components as shown in figure 1. Then the visual inspection of concrete finishes should be performed to look for any defects. The most important things is to perform before hoisting is to double check the position of the condition of lifting insert to ensure that the components safe during the lifting work as shown in figure 2. Delivery work. To avoid in-transit damage, precast elements should be loaded and transported with enough support, framing, cushioning and tie-downs as shown in figure 1 and 2. To reduce the danger of damage during shipment, adequate packaging or protection for the edge of precast part should be supplied. The suitable vehicles to transport the component that used in heavy-duty trailer because the trailer is suitable for the precast component capacity to carry the load as shown in figure 3. The vehicle center of gravity of the load should be as low as desirable. Handling work. When precast concrete components fulfill the target of concrete strength, they are lifted from the casting position to a storage area before being delivered to construction site. They are more likely to get damaged during handling. The handling requirement depends on the following factor, which is the first one is location of the casting mold. The precast component must have a minimum concrete strength for demolding, delivery and installation. Adequacy of the design reinforced to resist handling stress. Size and weight of the precast element. Number, size and location of lifting points to type of device. Method of lifting, type of lifting, equipment and crane capacity. The lastly is support points for storage and transportation. It is critical to ensure that they are handled in a manner that is consistent with their forms and size in order to avoid undue tension or damage as shown in figure. Figure 1 shows the hoisting method for the beam. Figure 2 shows hoisting method for the slab and the correct position for hoisting method for the column shows in figure 3.
My name is Norada binti Ali. I will present FILA table for this research. There are 4 FILA obtained for this research. FILA is abbreviation for facts, ideas, learning issues and actions. The first fact is structure and connections of IBS system used in concrete laboratory. The idea is to identify structure and connections of IBS system used in concrete laboratory. The learning issue is what are the IBS structure and connections used in the concrete laboratory. The action that we took is by doing site observation and find information in online database. The second fact is the IBS score in concrete laboratory. The idea is to identify IBS score for the concrete laboratory. The learning issue for this fact is what is the IBS score for the concrete laboratory. The action that we took is by doing site observation, group discussion and obtain information in online database. The third fact is the method of installation of the IBS component. The idea is to identify methods of IBS component installation. The learning issue are what are the suitable methods in installing the IBS component. The action that we took is find related information in online database. The last fact is the method of transportation of the IBS component. The idea is to identify the methods of IBS components transportation. The learning issues are what are the crucial factors and safe methods that we need to consider in transporting IBS components. The action that we took is find related information in online database. For overall FILA the action that we took mostly involves in obtaining information from online database.
Conclusion. As a conclusion, the IBS score of the concrete laboratory is still at the lower rate. Therefore, the implementation of IBS activity in the area is still less comprehensive. The limitation is the specified identically number of the IBS component of the real situation of the building is maybe different based on the real site. This is because of the less observation at the laboratory. So, for the recommendation is the study probably should get the real plan of the building by the local developer of the location itself for the correct identification issue. It is suggesting that to clarify all the limitations and consider the recommendation for a better refinement in the future study.